Now that you are experts at minerals, we're going to move on to rocks, which are made of minerals. There are three types of rocks, three rock groups, and I'm going to start with introducing you to each of those. First of all, we have rocks that come directly from magma or lava, and these are called igneous rocks. In this case, we have molten material that cools and crystallizes or solidifies and forms a solid rock. Very often, igneous rocks show crystals that you can see that formed as the rock cooled. And I'm going to show you an example of an igneous rock right here. Now, this one's been polished. It's been cut and polished. But what you should be able to see is individual minerals in here. And I know your expertise at minerals is still growing, but some of these are quartz, feldspar, and hornblende. So those are igneous rocks. The next type of rock is called sedimentary rocks. And sedimentary rocks often contain fossils, so I put this picture here. They can also include other features related to their environment. So I have another sample here. This is a sedimentary rock. It's rather thin. It's called a shale. But if you look closely at it, it has these features on it called ripple marks. And the ripple marks tell us that this rock formed in a shallow environment. Well, I should say the sediment that made the rock was representative of a shallow environment because we don't get ripples in deep water. You need waves to make ripples. And then eventually this was turned into a rock. The third kind of rocks are metamorphic rocks. And metamorphic rocks often have folds in them, and that's a pretty good indication that the rock has experienced pretty significant heat and pressure and changed. Here's a rock sample I have, and this one is metamorphic, and you can see the folds in it, and also the alignment of dark and light minerals. That's called foliation, and that's another important characteristic of metamorphic rocks. When you see a fold, you're pretty sure it's metamorphic, but sometimes when you see just layers, it might be layers from a sedimentary rock. So there are some tricks to learning the difference. Here are the learning outcomes for Unit 9B, so go ahead and pause the video and write these down. And now I want to introduce you to the rock cycle. This is one way that we can think about rocks, because rocks can change and turn into other rocks. Now the diagram is pretty complicated, I realize. It's from your lab, so I'm going to walk you through it a bit, and we'll get into some of the additional details later on. First of all, there are 5 sort of nodes or main components of the rock cycle, and you've already been introduced to 3 of them. There are igneous rocks, which are represented over here in the diagram, sedimentary rocks down here, and metamorphic rocks. Again, you can see some nice folds. The 2 other key components in the rock cycle are magma or lava, molten rock, and then sediments. So these are the 5 main components of the rock cycle. Then between each of these components is a process. How do you get from one to the other? And these are in the bluish, purplish, grayish arrows. I'm not sure what color that is. So let's look at those. First of all, to go from magma or lava to an igneous rock, you need cooling and crystallization. So that's the process. The magma cools and it solidifies, just like water, if you put it in the freezer, cools and becomes an ice cube. It solidifies. If you want to turn igneous rocks into sediments, you need weathering and transportation and deposition. And so those are all features that we're going to talk about right before we talk about sedimentary rocks. How do we make sediments and what kinds of sediments are there? Then if you want to take that sediment and turn it into a solid rock called a sedimentary rock, you need to undergo the process of lithification, which means to make it into a solid rock. And this involves taking those sediments, burying them, compressing them, squeezing all the water out, and then having a natural cement come in and kind of glue them all together. If a sedimentary rock gets buried and exposed to heat and pressure, it can become a metamorphic rock. And so that's the process here. Intense heat and pressure, sometimes referred to as simply metamorphism. If a metamorphic rock continues to experience intense heat and pressure, it might eventually melt. And that process brings us right back to the lava and the magma. So that's why this has always been called a cycle, because you could picture a rock going through the entire cycle. In general, rocks probably don't go through the entire cycle. There are some shortcuts in here that I'll get to later. But these are the main components of that cycle, and you want to make sure as you watch the videos that you're thinking about where in this cycle you are as you're watching the videos. So you're going to be expected to be able to read the classification charts for the igneous, sedimentary, and metamorphic rocks. These charts are in your lab, and those are the ones we're going to use. The charts you see in the videos might be slightly different versions. Don't be confused, just realize there's more than one way to make a chart. I'm going to show you the key components of each of these charts, and then you can compare them to the ones you see in the videos. So page 84 of your lab has the igneous identification key, and I'm going to blow up the top of it here. And the rocks that we're going to look at are listed here: granite, diorite, gabbro, rhyolite, andesite, basalt, and also obsidian. Now the charts will all have the following in common. In one direction, either rows or columns, you'll have the texture of the rock. And so in this case, it's going to be rows. And texture means the size of the mineral grains. It doesn't mean whether it's smooth or rough. So a coarse grain texture means that you can see the actual mineral grains. And that's this rock that I showed you earlier where you could see the actual minerals. The fine grain ones are too small to see. You could see them if you had a microscope slide, or maybe if you looked really carefully with your hand lens. So that's going to be one direction of the table. And then the other direction will be the composition. What minerals make up the rock? And so basically, to name a rock, you need to find the intersection of texture and composition. For example, this rock right here called a diorite has an intermediate composition, and it's a coarse-grained rock. So when you look at the identification key for igneous rocks in the videos, keep this in mind. Next, we have the classification charts for sedimentary rocks, and these generally fall into two major groups. I'll blow this up a little bit. We have the detrital sedimentary rocks, which form from physical weathering, physically breaking down the rocks into smaller pieces. And the names you're going to use are going to be from this column here. Then we have a very different kind of sedimentary rock called a chemical sedimentary rock. These are formed from chemical weathering and sediments that are essentially ions in solution. They're dissolved. And when they precipitate back out, they form rocks. And one of the more common rocks is limestone. So we have a bunch of limestones right here, different kinds. And then there's some others as well, including rock gypsum and rock salt, which are minerals we saw before, but when they occur in large giant deposits, they're sometimes referred to as rocks. Finally, we get to the metamorphic classification chart. And there are a lot of different ways to classify metamorphic rocks. I'm not a big fan of this chart, but let me blow up a little bit and show you. The names are here. And the reason I'm not a big fan is because there's something very important about these first four rocks that is just not clear on this particular diagram. And that is that these four rocks, slate, phyllite, schist, and gneiss, are a continuum of metamorphic intensity. The parent rock is what you start with before you get the metamorphic rock. So if you start with a shale, which is a sedimentary rock, and you metamorphose it, you'll get something called a slate. But if you continue to add heat and pressure, that slate turns into a phyllite. Continue to add heat and pressure, that phyllite turns into a schist, so on until you get something called a gneiss. Metamorphic minerals grow, other minerals disappear, so there's a lot that goes on during the process of metamorphism. So we have lots of videos to watch because we have lots to learn about this week. The first three are going to talk about igneous rocks, including plutons, which is the name for intrusions of igneous material that's not volcanic. Then you're going to look at two videos about sedimentary rocks, and the first one's going to have to do with weathering and that physical and chemical weathering that I talked about. Then you're going to look at metamorphism and metamorphic rock identification. So there's 7 videos here. They're each between 5 and 15 or 20 minutes, so it's going to take some time to watch them. And then when you're done with all of these, I will have video rocks 9b.9 to wrap everything up. Also, we'll be looking at rocks this week in lab, so make sure you watch these videos. It'll really help you get ready for lab.